Good day, everybody, and welcome to today's presentation on effective digestion, distilling, and brewery story, and how to make distilling and brewing more sustainable. My name is Jose Molina, and I am Manager of Business Development at Evoco Water Technologies. I am joined today by Kurt Rosentrader of Iowa State University. Kurt is also the Executive Director and CEO of the Distillers Grains Technology Council. And together we'll be presenting on the rise of the brewery and distillery industries and how these industries can make their processes more sustainable. We unfortunately cannot offer CEU credits for this webinar, but we can provide a certificate of attendance after today's presentation. Also, we will have time for questions at the end, but feel free to type any questions you have as they come up. You can use the chat window located on your webinar interface. My colleague Mike Stock here at Evoco will jump in at the end of the presentation and moderate any questions that you folks may have. Also, just so you know, this webinar is being recorded, and in a few days' time, you will receive an email with a link to the video from this presentation. With this, I pass the floor over to, sorry, this is still mine. I wanted to discuss a little bit the agenda, what we're talking about today. So Kurt was going to discuss the growth of the alcohol industry in general, some of the manufacturing processes and the products that can be generated. You know, on the one hand, you're producing alcohol, but you also have co-products and waste products that we are looking to manage in a sustainable way. So talking about sustainability, we'll jump in here with the need for alternatives. And more specifically, we want to discuss the use of anaerobic digestion as a sustainable solution for handling some of those waste products, waste streams, whether they're solids or liquids. So with that, I pass the floor over to Kurt. Thank you, Kurt.
Thank you very much, Jose. Thank you, everybody, for joining us today. You know, Jose did a nice job of introducing the topic, and in terms of looking at distillery or brewery processing and manufacturing, one of the biggest challenges that we face is the materials that are not fermentable. And depending on what we're producing, they will be a little bit different for every facility that we talk about or that we visit. So thinking about what happens downstream post-fermentation or post-separation with all of the either the stillage or the brewers spent grains, all of that impacts the concept of sustainability. And you know, we live in a society that is more interested in more sustainable living, but also sustainable solutions, sustainable products. And so I think it's important when we start talking about sustainability, really the context is threefold. The way to look at sustainability, it's not just about environmental sustainability, although that is important. There are other aspects of sustainability that we need to think about. And it's often seen through a lens of three pillars or three legs, if you will, also known as the triple bottom line, where we look at environmental sustainability, social sustainability, and economic sustainability. So when we initially talk about sustainability, the first thing that people think about oftentimes is the environmental aspect. You know, how can you reduce pollution that is leaving your facility, whether that's pollution to air, to water, to soil. But nowadays we're also thinking about carbon emissions, that you know, we may not be emitting carbon from our facilities, but the energy we use, depending on how it's produced, whether it comes from a nuclear plant, a hydroelectric plant, a solar farm, or wind power, all of that has a different greenhouse gas potential or carbon footprint compared to a typical coal-fired power plant. But part of the story is also looking at, you know, how can we make our factory operations more efficient? How do we improve our energy efficiency, our water efficiency? how can we reduce the amount of spent grains or stillage that we're either sending to the city or disposing of in landfills? So that's the environmental aspect. The economic aspect, of course, you can't or shouldn't do anything if you're going to be losing money. So long term, that's not a smart business decision. So whatever options you are looking at in your factory, you have to consider making money for the long term. So the social aspect sometimes is somewhat overlooked, but there are a lot of things that could potentially go into the social aspect because your businesses operate in communities. So if you are emitting pollution into the community, you're going to be impacting the residents or other businesses. So the other side of the equation is if you have developed a set of relationships with local farmers to use your stillage or your spent grains, they the customers you really need to foster long term, and so you have to take care of the relationships with those farmers. So the triple bottom line is a good lens to look at this whole idea of sustainability, both from environmental and a cost, but also a social standpoint. Oftentimes the triple bottom line is referred to as people, planet, prosperity. So you might see it cast in either form. Let's go to the next slide, please. Okay, so when we think about the alcohol industries, and today we're specifically talking about the distilled beverage industry and the brewing industry. So just taking a look at what's happening in the distilled spirits industry in the US over the last couple of decades, what we see is really an exponential growth in all types of distilled spirits, not just whiskey and vodka. But what we're looking at here, we're looking at the number of distilleries from 2006 to 2020. So this is a relic or influenced by changes in federal and state laws in terms of taxes, but also it's also a function of demand by consumers. And this follows very similar trends to what we see happening in the brewing industry over the last several decades too. So from 2006 in the US, we've moved from about 75 distilleries up to more than 2,000 distilleries in 2020, and that number is continuing to grow. All right, next slide, please. So it's not just the number of distilleries, it's the quantity of spirits that are produced. The more spirits you produce, the more waste products or byproducts you'll be generating as well. So looking at sales, the demand is strong, and the COVID pandemic has only strengthened sales. Looking at just from 2016 to 2017 alone, the sales volume increased by almost 25%. So we see this exponential growth running unabated, and predictions are that it's going to continue for the next several years. Next slide, please. The brewing industry, in similar respects, is growing exponentially as well. And this, again, is due to changes in state and federal laws, but also consumer demand. And I think more the beer side than the whiskey or the vodka side, there's a huge interest in home brewing and craft brewing, and that is helping foster the growth of craft breweries. So 2007, there were a little bit less than 1,500 breweries in the US, and then in 2018, there were more than 7,000. So this number continues to increase. All right, let's go to the next slide, please. So when you think about fermentation, you will be emitting CO2. And that's just part of the story. So if you had a perfect fermentation, the chemistry of yeast is such that for every kilogram of glucose you bring into your facility, into your fermenter, it's going to be almost an even split in terms of alcohol production or ethanol production and CO2 production. So the fuel ethanol companies really utilize this to their advantage because the glucose or the starch that's coming into the plant really represents revenue from the alcohol side. The brewing and the distilling industry is a little bit different. Most of the fermentations are not going to be running to utilize all of the glucose that's present in the grain that you bring into your facility. Rather, what we're trying to achieve is a specific flavor profile for the products that we make. And so we're really not going to be achieving this. We're going to actually be producing less alcohol, less CO2, and having more residual starch or residual sugars that are going into our stillage or our spent grains. Next slide, please. So just to briefly talk about manufacturing steps. So if we were to look at a typical large-scale distillery, so we would start at the storage of some type of cereal grain. Oftentimes it's corn, but there's also barley, wheat, rye, rice. We go through a milling step. We do some kind of a slurrying step. We do a cooking to do a liquefaction of the starch, but also sterilization of the cereals that are coming into the plant. We add the liquefied starch to the fermenters. We add yeast, we add water. We may or may not be adding enzymes. It depends on our production facility. It depends on the products we're making. So if we're not adding exogenous enzymes, we'll be adding malt. So after the fermentation is done, we will run the alcohol and the stillage through a set of distillation equipment. Sometimes we'll have tower distillation columns, sometimes there'll be pot stills, but ultimately we're trying to remove the alcohol because of the difference in boiling point, and then the water and the non-fermentable materials. Depending on the operation that you have, there are a lot of ways that we can utilize those non-fermentable materials. And what does that entail? Protein, lipids, fibers, minerals, non-starch polysaccharides, the things that are not going to be converted into alcohol by the fermentation by yeast. So depending on the type of factory that you have, you might have a range of options for taking those non-fermentable solids, separating them, maybe separating the dissolved solids from the suspended solids, doing some type of a concentration, maybe some type of a drying step. It really depends on the size of the operation. The larger the operation, generally speaking, the more options you'll see implemented. But it's a fair statement to say that depending, if you have a large scale distillery, you might be using up to a third of your plant's energy budget just on processing of the byproducts alone. All right, let's go forward to the next slide. If, however, you're a medium or small scale distillery, the question is, can you afford to process all of these solids into some type of an animal feed with some type of a concentration, separation, drying step? Most companies struggle with this, and that's just something that that we have to deal with. And many companies send their stillage down the drain. They pay the city fines or surcharges to have the city treat their waste solids. But what we're really talking about is a lost opportunity. And depending on where you're located, some distilleries are finding that the disposal of the stillage is a potential challenge in terms of growth of their distilling operations. It's not necessarily the land footprint that is limiting their growth, but the ability to dispose of the solids. So many companies will send the stillage to local farmers as a cattle feed ingredient. But if you're in the middle of a city, it's not always so easy to have a tanker truck fleet to move the stillage out of the city to the farms. And some depending on where you're located, sometimes the demand for this feed ingredient is just not, there's not enough demand to utilize all the stillage. All right, let's jump to the next slide, please. So composition wise, if we're looking at the various options for concentration, distillers wet grains or DWG, oftentimes you'll see larger distilleries separating the suspended solids. And what you're going to see is on a dry matter basis, that material, depending on what the cereal grain is, can be up to 45% or more protein content, and which is really fantastic as a cattle feed. The problem with distillers' wet grains, because it's a wet product, we're really talking about, somewhere between 55 and 65% moisture content. It really has a very short shelf life, and most distilleries are going to find that the wet grains won't last for more than a week before they become too moldy for the use by animals. But what you're going to notice in this slide, they're going to be really high in neutral detergent fiber, NDF. Here you see almost 29%. Going to be high in leucine, high in some minerals as well. Let's go to the next slide. If you dry the wet cake, the distiller's wet grains down, you'll generally produce some type of a distiller's dried grains. It might have solubles or not, the dried dissolved solids. Typically speaking, we're going to see protein concentrations from about 25 to about 35% on a dry basis. We're going to see a fairly high fiber content on a dry basis as well. And depending on the completion of your fermentation, we'll see generally somewhere between 5 and 30% starch content, depending on your fermentation operations. This has a shelf life that could be anywhere from up to a couple of years or more. Because generally the moisture content is going to be less than 10%, and so it's shelf stable. Let's go to the next slide, please. If we think about malt whiskey production, it's a little bit different than your grain-in types of beverage production. So in this case, we have a grain-out fermentation where we mash the grain, we extract as much of the sugar as we can, we send the solubilized sugars into the fermentation, and all of that spent grain then leaves the mash tun as draff. And sometimes you'll run that through a centrifuge. Sometimes companies won't. They may sell their draff wet, or if they run it through a dryer, they may sell distillers dark grains. In many respects, similar to what a grain-in type of fermentation will provide. The fermentation with the sugar stream, grain-out fermentation, we may have pot ale, we may have spent lees as well. Not all of the fermentation will go to completeness. So there may be some other streams that we have to deal with. And again, what many of the smaller distilleries are doing is not necessarily sending or drying these down into dried grains. That's generally the larger distilleries that do this. Generally, the small and the craft scale distilleries are utilizing the city systems to deal with their wastewater streams. Next slide, please. If we look at the composition on a dry basis, what we're going to see is some similarities with the grain-in fermentations. So generally, looking at the draff or the wet grain, similar to DWG, about 20% protein on a dry basis. Distillers dark grains, which are dried, will get a little bit closer to 30%. These will follow and track, in many respects, the cereal grain that you use. If you're using more rye and corn, or if you're using just corn, the nutrients will change just a little bit. So let's go to the next slide, please. So from a beer processing point of view, in many respects, there's a lot of similarity to a malt whiskey type of production where we do a mashing step. We try to remove as much of the solubilized sugars as we can so we can run those through the fermentation. So the spent grains that are going to be coming out of our lauter tun or a mash tun are going to be very similar in many respects to what we see from a malt whiskey type of production. Again, there may be some lees or some pot ale that we might be removing from fermentation, but not always. So the spent grain is in many respects going to be quite similar to what you'd see from a malt whiskey production. Let's go to the next slide, please. And if we look at typical composition for brewer spent grains, depending on the scale of operation, the smaller and the medium-sized breweries are typically going to have their byproducts in wet form. Some of the larger breweries have installed dryers and they produce dry spent grains. But on a dry basis, we're really talking, anywhere from 20 to over 30% protein. So very similar to what you'll see from a malt whiskey type of production, because it follows the same type of sugar extraction process. So the other nutrients, the ash, the lipids, the fiber, those will all track with the type of cereal grain that you're using. Again, depending on the extraction of that sugar from the endosperm of that grain, you may have more or less residual starch left in that spent grain. Next slide, please. So when we think about the growth of the beverage industry, whether it's spirits or beer, what we're really talking about is growth in byproducts. And I think it's really important to consider the byproduct side when you're talking about sustainability, both the environmental, the economic, as well as the social aspects, the triple bottom line. So if you make an estimation, and this is just a crude estimation, that for every gallon of alcohol that you produce, whether it's beer, whiskey, vodka, somewhere between 8 and 15 gallons of stillage per gallon of alcohol. What we're seeing really, if you go back a few slides to the growth charts that I showed you, no, sorry, Jose, I didn't mean to go back, but sorry. From 2012 to 2017, really what we're talking about is a growth of about 42 million liters of spirits in the US, which is essentially the growth of about 420 million liters of stillage and spent grains. So there's a lot of byproducts that our industries need to deal with, and there's no magic bullet. Separating your solids, drying your solids, sending them to cattle yards, swine and poultry production facilities, those work, and they work very well, especially for the fuel ethanol industry. But you have to have a scale with which you can afford to install the separation and drying equipment. For the craft and the medium scale breweries and distilleries, they don't always have the capital to afford that. So the challenge that we have, especially from a sustainability point of view, how do you deal with these products? Yes, there's a lot of nutrient value, but if you can't afford to install centrifuges and dryers, what do you do? And if the city is no longer allowing you to increase your load to the municipal system, that's going to be a constraint to the growth of your operations. So I'd like to hand it over to Jose to talk about anaerobic digestion as one potential option for breweries and distilleries, as in terms of an option that may work better for some of the smaller scale companies.
Well, thank you, Kurt, for that discussion. So this is a great way to summarize what's going on in the distillery industry. So on the one hand, you have production of alcohol. On the other hand, you have all those elements that you have to deal with after you've made your alcohol. There's the byproducts, there's the liquid streams, there's the solid streams. And again, the discussion here is how do we do this in a more sustainable fashion? And we're like Kurt said, we're not talking about just an environmentally sustainable way. We're also talking about the social aspects of it all, the economic aspects of it all. So just to recap here, so when we have a distillery type of operation, you're generating an alcoholic spirit from whatever sugar source that you have, depending on the region, depending on what it is that you want to grow. So whether it is you're making a whiskey or bourbon, you can be making rum from sugarcane molasses, tequila from agave. These are all different sources of sugar that you're using to make this great product, which would be a spirit. But you're also, whatever you're using as your source will affect what those co-products or byproducts look like. Okay. So what does that stillage look like? If you haven't removed the water, if you still have a water and whatever organic matter is still left over after fermentation and distillation, you have a product that has a very high organic content that can be used as food for cattle if you were to dry the product and again use it as a value-added product for your farmers, for cattle food or piggeries, whatever it is. What we are looking at is, what if those options are not all at your disposal? Then you will have to look at sustainable ways of handling the byproduct. Similarly, in the brewery industry, you are taking barley, you're using the soluble sugars out of the barley to make beer, and then you will have various waste products coming out of that process. Okay, so in the brewery industry, since you are not doing the distillation process to separate the alcohol, the waste material coming out of a brewery plant would be a lot weaker in terms of organic strength, but it's still a potential source of food or a potential source of energy if the idea is to take the energy in the form of biogas out of that wastewater. So again, as Kurt was saying, evaporating that water from the stillage so that you can use it as a dry product, it is a very energy intensive process. So the larger distilleries might have this already resolved. Some of the smaller or medium-sized distilleries would still have to dispose of that material in a different way. Maybe it's too intensive from a capital point of view and also from an operating cost point of view. Transporting that waste material that's coming out of the stills carries a transportation cost. It carries an environmental cost as well. But as I was saying earlier, you can look to turn these waste materials into a potential revenue stream. The idea is to do it in the most sustainable fashion that you can. The reason that we're discussing here with Evoqua is the fact that we can look at taking those waste materials and turning them into biogas as a green source of energy for a lot of these processors. This is a solution that could meet the sustainability objectives for a lot of our customers. You're looking at energy recovery, and you're also looking at independence for your operation in terms of how to generate your own energy, and also not have to depend on third parties, outside parties, to take away those waste materials from you. So really what we're looking at, the process is the objective of the distillation plant or the producer is to optimize the production of alcohol here. This process of once you've made the alcohol and cleaning it, bottling it up, there will be generation of some waste material here. But really what we want to concentrate here on this discussion is, what do you do with what comes out of the bottom of those stills? Similarly, here, if you're making whiskey, you will have those waste streams coming out of the mash tun, but also what comes out of the bottom of the evaporation process. So we are one alternative is to separate and dry, and then you have the solid material that you can get some value out of. Or the alternative that we would like to discuss for some of our customers, it would make more sense to take these two streams and put them into an anaerobic digester that can recover the energy that's still in it. Rather than using it as feed, you're using it as feed to a digester for turning it into biogas. So the brewing industry can be quite similar as well. So this is Kurt's graph. What you see is spent grains that often usually are used as cattle feed, and then you have at the bottom the brewing process, and the bottling process will have a generation of a more liquid stream with a lot of the organics are in soluble form. But let's not forget that you also have waste yeast, so spent yeast, and spent hops that are also a byproduct from the brewing industry that our idea is to always looking for sustainable ways of handling that material. So I have a couple of examples of case studies of where we've been able to do this, looking at sustainable ways of handling these waste materials. So a couple of slides on this application that we did for New Belgium Brewery at a plant in Asheville, North Carolina. So this was a brand new operation that was being built in North Carolina. As you know, New Belgium came out of Colorado, but they found a lot of success, and they built a brand new facility in North Carolina. But of course, you're within the city limits. You have limited space to do your brewing and your wastewater treatment. And the company was looking for a good, sustainable way of handling the waste stream. They had resolved the issue with what to do with spent grains, but they had not. They were looking for sustainable alternatives of how to handle the spent hops and the spent yeast. So in this case, what we came up with was a solution that would handle both the liquid stream, the processed wastewater from brewing, the brewing operation, but combining that with the waste streams from yeast and hops. The solution is an anaerobic membrane bioreactor that can convert over 99% of the BOD of the organic matter in that wastewater and turn that into biogas. So this is a very sustainable approach to the management of both the liquid and solid stream. The effluent from our reactor is very high quality, so it can go to the city sewer without paying very high in terms of surcharges, because most of the organic matter has been removed from it. And of course, we're using the biogas, we're recovering the biogas and utilizing it in a form of energy recycling. So it's a sustainable way of taking that energy out of the beer wastewater and turning it into a source of green energy. Very quickly, here is a simplified process flow diagram. We have the wastewater at a strength at about 14,000 liters COD, so a bit weaker than a distillery effluent, but still relatively strong compared to most typical brewing wastewaters. The combination of spent yeast, hops, and soluble organic matter goes into an anaerobic reactor. This is where most of the activity takes place, and the organics get turned into biogas. And then the combination of biomass and treated effluent is sent to a membrane tank where liquid effluent goes out as a clean discharge for sewer, and the solids are retained and either returned to the main anaerobic reactor or wasted as digested waste solids that can be land applied. So very quickly, some operating results. You can see that as wastewater with a COD of almost 10,000 milligrams per liter, you have over 98% removal of that COD. So all of that sugar and protein that's still left in the wastewater is being converted to biogas. So, and very little in terms of suspended solids, in terms of waste solids coming out of the plant. This is a very stable process, and I think you don't need to get into the details here, but COD as a measure of organic load, very variable from a typical brewing operation. And what you have is a very stable organic concentration in the effluent from the anaerobic reactor going out to city sewer. So again, all of that COD that you see here on the blue dots is being converted to biogas and utilized rather than being sent out for the city to treat at a much higher cost. So just to summarize, this is a green solution for treating wastewater from a brewing operation. The anaerobic membrane bioreactor was a great advancement in the technology, and it consistently maintains very high performance over year after year, month after month. the solids, the waste solids that we would otherwise have to dry and transport and find somebody to take away from you. Instead, they're being being kept internally to the plant and being converted to biogas. So that's energy that can stay within the production plant. Going on to a slightly different type of spirit, this is an example of a tequila plant down in Mexico. Again, as we talked about before, any type of distillation process that produces a spirit will create a stillage product that needs to be handled. In this case, what we have again is the ability to take the whole stillage with solids and soluble and non-soluble organic matter, and we can treat that directly in a low-rate anaerobic reactor. These are very large tequila production facilities, so the capacity is much larger than the system that you saw before at the brewing facility. So 55,000 kilograms of COD per day, that corresponds to maybe 120,000 pounds of COD if you want to talk about imperial units. And very important here to note is that you do not need to separate the solids and try to find somebody to take the solids from the plant and take that for some kind of use. This is the circuit is closed here so that both the solids and the soluble organic matter is being digested and taken into biogas. The system's been running for maybe a year and a half, and it's obviously meeting the customer sustainability and environmental stewardship objectives. Another good example of taking a stillage and rather than drying, you actually digest it. This is a sugarcane molasses distillery out in Thailand. Even higher concentration, even larger organic loads being taken to an anaerobic digestion system. Again, without having to remove the solids, we're taking the whole stillage from that plant and taking that to biogas. In the case of the sugarcane molasses distilleries, if you digest the whole stillage in an anaerobic reactor, you're creating enough energy in the form of biogas that it can make the process of distillation self-sufficient. So there's enough sugar and protein and other organic matter left in the stillage that if you digest it and convert to biogas, you can actually run the distillation process. There's enough green energy in there. So self-sufficiency, sustainability are the key drivers for projects like this that we've done over the years. So thank you very much for attending our presentation today. We will open the floor for discussion. Here's some contact information if you want to follow up with questions after today's day.
Hey guys, thank you for that, Jose and Kurt. That was awesome. I have some questions that have come in, and Kurt, I'll start with you. This may be you mentioned the pig feed and stuff, but this might be geared for people who live more in the rural areas. But the question is, could you describe the livestock feed opportunities with these types of byproducts and co-products?
Oh, absolutely. Thank you, Mike. Because when we're talking about making beer or whiskey or vodka, we're talking about a cereal-based fermentation, and I'm specifically talking cereal fermentations right now. When you remove the starch or a portion of the starch to do the fermentation, what you're essentially doing is concentrating the protein, the fat, the fiber, the minerals. And when you're talking about the greatest opportunity, because most of the cereal grains are going to be fairly high in fiber after fermentation or after the sugar extraction, both beef and dairy cattle are really a good target for using these types of spent grains, whether wet or dry form. And some farmers have done, they've been very successful in feeding these types of byproduct feeds up to 50% of their diet. And that's like a feedlot type of situation. If you're talking about a pasture or rangeland setting, oftentimes they're used as supplements as opposed to complete feed. Now, if you are able to install a drying system, and you bring the moisture content down to about 10%, we're really talking about bumping that protein content up just because of mass balance. And if you're talking somewhere between 25 and 35% protein, those have been really effectively used in a variety of feeds for cattle also, but also for swine and for poultry. And I know swine producers here in Iowa that have, depending on the price of competing ingredients, fed up to 40 or 50% of the diet to their pigs. Chickens and turkeys are a little more sensitive, so what I've seen is the highest rates generally are about 15 to 20% of the diet for chickens and for turkeys. So I think there's huge potential, but not everybody is in a position to dry their ingredients, number one, to ship their ingredients to the farmers, number two. And I've talked to a lot of breweries and distilleries, small scale. They give away their spent grains because they just want to get rid of the problem. And maybe the farmer will give them a couple of steaks every year or something like that. I think that's a missed opportunity in terms of revenue. But not every brewery or distillery has that option of shipping their spent grains to a farmer. And so that's why a lot of them have gone to just dumping their stillage down the sewer and letting the city deal with it.
Yeah, well, thank you for that. That's really great. And here's a question that is kind of the opposite of that. So I'm going to combine them into one. But here's a question that says, I have an urban distillery, relatively small. Are there systems that are smaller than the New Belgium example? And I'm going to tie that into another question, which is, there was a slide that had solids to disposal. What do you do with them? So I'm going to kind of tie those two. So what do you do with your solids to disposal? And then if someone has an urban distillery and it's kind of small, what are his options? Are there something that we have, any options that we have that are smaller than New Belgium?
Okay, so I'll start and maybe Kurt can add to my comments. So first of all, on the waste solids to disposal. So I should have maybe clarified that after you go through anaerobic digestion, the raw solids that went into the anaerobic digester, if they're organic, they're going to be converted. Most of it is going to be converted to biogas, but there will still always be a fraction of that solid matter that will end up as waste solids coming out of the system. But it's important to note that once you take the organics out of it, or you've had the organic solids in the anaerobic reactor for weeks and months at a time, those solids have been stabilized, or mineralized is an expression that is often used. So this is a stable solid that can actually go back to the land. It has still the minerals in it, so it might return some nutrients back to the land, but it will be stabilized, so it will not create any problems in terms of odor concerns or vectors or things like that as you put those back into agricultural land. The question about scale, I think that's a very good question. So a lot of the time when we're talking about distilleries, even though the flows may be small, we're still talking about a very large load because it's very concentrated material. So I think we can go there. A small distillery may still be a candidate for anaerobic digestion. It will be a system that's smaller than what you saw there on the pictures of the brewery, or the pictures of the systems down in Mexico or in Thailand. So it's all a matter of scale, but I think anaerobic digestion still makes sense economically, and from a sustainability point of view, you would still have good candidates. It would be a case of studying specifics of your distillery, and we can come up with a sustainable solution for that application.
Awesome, thank you. And then there's another question that came in. again, it was about scalability, but the part of the question is, could one system work for a distillery that produces multiple spirits and utilizes grain as well as other waste products for spirits, such as fruit or sugarcane? So probably, in other words, can anaerobic digestion work for a brewery as well as a distillery, or are there different things? Or if it's not anaerobic digestion, what might it be?
That's an excellent question. And I would say that generally, yes, an anaerobic reactor can handle that variability in your feedstock at the distillery end. So the stillage will change characteristics depending on what it is that you're fermenting and then distilling. But if you size the anaerobic reactor properly, what you have at the end is the non-fermentable, the protein that didn't turn into alcohol. You have a lot of organic solids. So knowing what that variability is will help us to size the system properly. But yes, definitely you can digest material that's coming from different original feedstock going into the anaerobic digestion.
Cool. The next one is for you, Jose. What is the best way to utilize the biogas that gets created?
Yeah, that's a good question, and it's one with a very open-ended answer. So a lot of the time it has to do with scale. So for very small systems, maybe the most economically attractive solution would be to put that biogas back into process boiler. So to drive that energy need in the in the distillation process. So you need a lot of steam. Bringing that biogas to create steam might be the easiest and quickest solution. As the system gets bigger, you would look at maybe other types of biogas utilization systems that may have a better return on investment, maybe higher capital cost, but the value that you get out of the biogas might be better. So we could be talking about electricity generation. Very large distilleries might be looking at purifying that biogas and putting it back in the natural gas pipeline. So again, those would be it's a question of scale. It's a question of the quality of the biogas, and it's also your local conditions. So there's a whole matrix that we would have to look at in order to come up with the best solution for how to use the biogas in different locations, different sizes, different types of plants.
That's great. Thank you. Kurt, how are most breweries, or how do most breweries and distilleries, how do they deal with their non-fermentables?
I think I've alluded to this the last couple of times that I've been talking in terms of, oftentimes, especially the small scale distilleries, it's a manual process. They fill a tote. The tote sits behind the building, and once or twice a week, a local farmer will come and pick up the tote and then feed it to their cows. So that's typical for a lot of the small scale companies. Larger scale companies, well, I better back up. When we're talking about separated solids, the spent grains, stillage, if you're not doing any type of screening or separation of those suspended solids, oftentimes that stillage will just be put directly in the municipal city system. If you're talking a little bit larger scale, oftentimes breweries or distilleries will send that stillage through some type of a small scale screen to separate the suspended solids. So they have a suspended solids stream that they put into a tote, and then the dissolved solids and water they just send down to the city system. So unfortunately, the city systems are heavily used by a lot of breweries and distilleries, and it works kind of, but it's not really a sustainable format, especially if we're talking long term, because that's a load on the city, because that organic matter has to be dealt with at some point. So really what a lot of cities are doing, especially where we see large scale growth, you think about different cities throughout Kentucky, for example, where bourbon is booming. The cities are becoming stricter and stricter in terms of the loads that they'll accept, and that often becomes a constraint. So what do you deal with it? Well, you don't expand. or you up your farmer base. So I think really what we're talking about is if you can utilize a different technology, it's easy to say, let's feed cows. It's more difficult to actually do it, especially if you're in an urban setting. But I think we really need to get outside of the box and say, well, we've got carbohydrates, we've got proteins, we've got carbon. It may not be in the form of starch or glucose, but we've got carbon and nitrogen. How can we utilize those molecules in a different way and get outside of this livestock paradigm? And I think that's going to be really critical as we move forward, especially if you think about all three aspects of the sustainability story. You know, how do you get outside of this livestock box? Not that there's anything wrong with that. It's been very successful. We've fed livestock our non-fermentables for thousands of years, but we really need to get outside of the box if we're really talking long-term sustainability.
Awesome, thank you. The last question seems to be more of an equipment-based question, but the question is, how do the waste solids get removed? I'm guessing that's, you see a tank, and then in one picture you see the big tank, and the next picture you see your land applied or it's dried. How does it get from the tank to a big pile of dried good? I mean, maybe that's what the question is alluding to.
So I'm not sure, Mike, if that's the question is alluding to waste solids from the anaerobic digestion step, or the solids, dried solids from distillers' dried grains that Kurt was referring to. If it is about the digestion part of this discussion, the anaerobic digesters, you know, you have the biological system, everything is happening inside of that tank. You would normally have an outlet where you can pump out solids. So these solids are still pumpable. Most anaerobic digesters, the concentration of solids at the bottom of the reactor might be in the 4 or 5% range. So if that waste sludge that's been stabilized can be directly land applied, it would just be pumped directly into a tanker truck and then put taken to the fields. If there is a longer distance to travel, or if there are requirements and locally to land apply at the water sludge, you would have to go through an intermediate step where you go through whether it's a centrifuge or some kind of waste sludge dewatering system, and then you turn it into a product that's no longer pumpable. It would be more of a truckable type of sludge that then has to be land applied with a tractor or something similar.
Got it. Well, that is the last question, gentlemen. Thank you so much for your time. If anyone else has any questions, type them in or just email. My recommendation would be to email Jose or Kurt, and they will get back to you ASAP. And we will have a link out to you in a couple of days to link to the webinar so you can watch it again, get what you need from it, or send it on to others who may need it. So thank you.
Thank you, Mike. Thank you, Kurt, again.